everyone, and welcome back to our channel. Ever wonder how to make learning super fun for your kids, right from the comfort of your own home? Well, today, we're turning our houses into amazing science labs. Get ready for some mind-blowing, easy-to-do experiments that your little ones will absolutely love. It's all about getting hands-on, asking questions, and discovering the magic of science together. So, grab your imaginary lab coats, and let's get experimenting. First up, we're diving into the world of chemical reactions with a classic that never fails to amaze. The baking soda and vinegar volcano. It's simple, it's safe, and the payoff is huge. All you need is a bottle or a cup, some baking soda, vinegar, and maybe a little bit of food coloring and dish soap to make it extra foamy and colorful. Here's how you do it. First, place your bottle in a tray or a pan to contain the eruption. Trust me, you'll thank me later for this tip. Add a few tablespoons of baking soda into the bottle. Then, in a separate cup, mix some vinegar with a few drops of your favorite food coloring. Want more bubbles? Add a little squirt of dish soap to the vinegar mixture. Now, for the grand finale. Pour the vinegar mixture into the bottle and watch the magic happen. Whoosh! You've got an instant volcanic eruption, but what's actually going on here? When baking soda, which is a base, mixes with vinegar, an acid, they react to create carbon dioxide gas. It's this gas that builds up pressure and erupts out of the bottle, just like a real volcano. It's a fantastic way to introduce the concepts of acids, bases, and chemical reactions. Let them try different amounts of baking soda and vinegar to see if it changes the eruption. Science is all about experimentation. All right, moving on from chemistry to physics with our next experiment, the amazing floating egg. This one is a real brain teaser and a great way to learn about density. For this, you'll need a tall glass, water, salt, and a fresh egg. First, fill the glass about halfway with regular tap water. Gently place the egg into the glass. What happens? It sinks right to the bottom. This is because the egg is denser than the water. But what if we could change the water? Now, take the egg out. Start adding salt to the water, a few tablespoons at a time, and stir until it dissolves completely. You'll need to add quite a bit of salt, so be patient. Keep adding and stirring until you've got a really salty solution. Time for the moment of truth. Gently place the egg back into the salt water. And look at that! The egg is floating. How cool is that? By adding salt, we increased the density of the water. Once the water became denser than the egg was able to float on top. You can even take this a step further. Try slowly adding fresh water on top of the salt water. If you do it carefully, you can create a layer of less dense water on top, and the egg will hover right in the middle. It's like magic, but it's actually science. Ready for our third experiment? Let's explore the power of air pressure with the incredible can crusher. A quick safety note. This one involves a hot stove, so adult supervision is absolutely essential. You'll need an empty aluminum soda can, a bowl of ice-cold water, a stove, and some tongs. First, pour a tiny amount of water into the empty can, just about a tablespoon or so. Then, using the tongs, place the can on the stove over medium heat. You want to heat the water inside until you see steam coming out of the opening. This steam is pushing the air out of the can. Once you see a steady stream of steam, it's time for the action. This is the exciting part. Using the tongs, quickly and carefully grab the can, turn it upside down, and plunge the opening into the bowl of ice-cold water. Bam! The can will instantly implode with a loud crush. So, what just happened? When you heated the water, it turned into steam and filled the can. When you plunged it into the cold water, the steam inside rapidly condensed back into a tiny amount of water. This created a dramatic drop in pressure inside the can. The much higher air pressure outside the can then crushed it instantly. It's a powerful and dramatic demonstration of how strong the air around us really is. Isn't that wild? Let's switch gears to something a little more colorful. The walking water experiment. This is a beautiful and mesmerizing way to learn about capillary action. You'll need a few clear glasses, water, paper towels, and food coloring in primary colors, red, yellow, and blue. Line up 3 glasses. Fill the first and the third glass with water, but leave the middle one empty. Now add a few drops of red food coloring to the first glass and blue food coloring to the third. Give them a good stir. Next, take a paper towel, fold it into a long strip, and place one end in the red water and the other end into the empty middle glass. Take another folded paper towel and place one end in the blue water and the other end into that same empty middle glass. And now we wait and watch. Over the next hour or so, you'll see the colored water walk up the paper towels and start dripping into the empty glass. The water seems to defy gravity. This is capillary action at work, the same process that helps plants draw water up from their roots to their leaves. But wait, there's more. As the red and blue water mix in the center glass, what do you think will happen? That's right, they'll mix to create a whole new color. Purple. You're not just learning about physics, you're learning about color mixing too. You can expand this by using more glasses and all three primary colors to see what other new colors you can create. It's a living piece of science art. For our final experiment, let's play with static electricity and bent water with a balloon. This one is super simple and feels like you have superpowers. All you need is a balloon and a head of hair, or a wool sweater, and of course, a faucet. First, turn on your faucet so you have a very thin, steady stream of water. Make it as small as you can without it just dripping. Now, take your balloon and inflate it. The magic step is next. Rub the balloon vigorously against your hair for about 10 to 15 seconds. You're building up a static charge on the surface of the balloon. You might even feel your hair start to stand on end. Once it's charged up, slowly bring the balloon close to the stream of water, but don't let it touch. Watch closely. As the balloon gets near, the stream of water will magically bend towards it. So, what's the secret? When you rub the balloon on your hair, it picks up tiny invisible particles called electrons, giving the balloon a negative charge. Water molecules, while neutral overall, have a slightly positive side and a slightly negative side. The negatively charged balloon attracts the positive side of the water molecules, pulling the whole stream towards it. It's a fantastic visual way to understand static electricity. How many times can you bend the water before the balloon loses its charge? And that's a wrap on our home science lab adventures for today. We've made volcanoes erupt, floated an egg, crushed a can with air, made water walk and mixed colors, and even bent water with a balloon. Remember, science is everywhere, and it's all about being curious. The best part of these experiments is not just the wow moment, but the questions that come after. Ask why, explore what happens if you change something, and most importantly, have fun discovering the answers together. Thanks so much for joining me today. If you tried any of these experiments, let me know how they went in the comments below. Don't forget to like this video, subscribe to the channel, and hit that notification bell so you don't miss our next adventure. Until next time, keep exploring and stay curious. Bye!